Hello everyone, and welcome to another Miss Online Consultation. And Imad was actually a couple seconds ago saying that I'm gonna say the same exact two phrases, and I want it to be exactly in the recording. So there you go. So you have it. Apparently I'm speaking in a template kind of way, and I'm a very predictable guy, which is really okay. I'm fine with it. I'll have to live with this problem anyway. Without further ado, we're gonna append on the last lesson, and Almir, he doesn't have psychic powers. He just watched too many video lessons of mine. In this lesson, we're gonna talk about build upon or append to our latest lesson. So the last lesson we were talking about the actions, functs, lambdas. We're gonna talk today about, we were talking about delegates last time. We're gonna append to it actions, functions, action, func, lambdas, yield, writing a generic method to show you how this is actually could be written, and show you how extension method looks like and how it works. And yeah, this is it. I think this is it for this today's to-do list. So let's hope that we're gonna actually finish on time. Alright, so as you can see here, throughout the code which we had since the last time, we had so much code in there. Like, if you see here, okay, I've shown you already the generic methods, I think, the last time. So we can take this out of our to-do list. However, I would like just to delete these parts. So I'm gonna delete this, because we don't need them anymore. And I'm gonna delete all these guys as well, right there. So yeah, so we basically have a delegate, a bunch of delegates. One delegate which is not generic one, which takes an integer and returns a bool. And we created a generic delegate for our generic methods. And there you go. Are we good with the zoom, guys? Sorry, I just noticed lately that you guys were okay having problem with the zoom. All right. So basically, what we have here is too much code in our hands. I mean, if I'm surrounding this with a region for now, let me just push this into a region, and let me move these guys. So this is my own built employee test bed. So this is my test bed. This is where I start, testing my classes. And in fact, I'm gonna just grab this whole thing, move it away, Shift Tab. So just keep it away for now. I'll just combine it, and this is it. So this is our this is our old employee, and I will just keep it that way. And yeah, we don't have any more this filter list with the non-generic one. This one with the delegate, I will even delete it, and I will keep everything probably the same right now. I'm just clearing out the stuff which we don't need. And by the way, this is still too much code. And in fact, you know what? Let me even delete those. Sorry about that, but let me delete all the ones. And imagine that you are writing in fact a framework, right? And you made a method, and this is how, and you have only one single method, and this is how to use it. And if we ignore this, well, we'll ignore that piece and ignore that piece where you start adding employees, you will end up with the following lines of code. The first code is this piece, and the second code is that piece, or actually this piece. Now we replaced using methods like these with lambdas. Okay, so lambdas are much more convenient in order to use them, and instead of just writing these methods. However, you could run into a problem that you have, let's say, a multi-line lambdas. Let's say you want to have something like here, something like this. I mean, I'm just improvising right now. Actually, imp dot name. You know, for instance, you wanted to print out the employee's name in the middle of the whole thing, right? And how could we write a lambda that represent this, or how can we have a lambda that takes 2 arguments? You know, right now this is how we're gonna start formulating our lambdas. Now, honestly, I don't have a concrete. I mean, I haven't prepared a concrete kind of example of a function that takes 2 numbers, but I will show you the syntax in case if you have seen a lambda or let's say a delegate that takes 2 parameters. So let's take the easiest one first. Let's say you would like to have multi-line code here. Now, if you would like to go that road, you will just simply open a curly bracket, and at the end, of course, I will close it. And right now, you're gonna start writing a real code. Right now, it has to be like this. I think e.name, right? Semicolon. So there you go. So this is how you would like to write a multi-line lambda. Right now, you open a curly bracket exactly like in a method, and you start putting down your code. So this if you would like to have this multi-line function. Remember that, again, lambdas are being used only once. If you would like to use them repetitively, if you would like to use this action repetitively, then it is advised that you separate it into a separate method and just simply call it. Instead of just, you know, making the compiler duplicate it for you over and over again. Okay. Now, what if we have a method, or we are looking at a delegate that points to a method that doesn't take any parameters? You will write it like this: open closing brackets, and then you write in whatever you want it to write. Now, of course, it's an error because our delegate here requires to have a number, is it? But basically, this is your syntax. So this converts into this, I think, no, bool. No params method. And right here, you type in e.salary. But of course, since you don't pass anything, this actually should be failing. But here is the same as this one. You see, I will say return e.salary less than 2000. So this is the same as this. Okay? Now, this is without parameters. If you would like to have parameters, you will keep those guys. So you open one, you put your parameters, which you would like to have, and then you close the bracket. And then here, you start playing with them. Okay? But of course, your predicate or your delegate has to point to a method that takes those 3 parameters. Okay? So this is how to write a lambda without, you know, for pointing to a method that doesn't take a parameter. It takes 1 parameter. It takes several parameters. It has to be different letters. Okay? And this is it. Okay? This is what I wanted to hammer down on regarding actually this part about lambdas and how to write them in a different form. There's one more final thing I would like to cover about delegates, and it is I wanted to talk about the part where delegates, because I said delegates are types, and you can instantiate, and a type is just a thing that you instantiate an object out of, or instantiate an instance out of it. And let me see here. I hope it's really compiled. At least I hope, because I wanted to show you. I mean, I hope it's there. Program. Let me see here. No, this is not the compiled one. Let me hit Control-Shift-B. Recompiling it, and let me hear. I hope it's refreshed. Is it? It did. It did, which is great. Now, unfortunately, yeah, I cannot get the actual code. Unfortunately, I mean, you see, using generics, because everything is just compiled, it's a compile time thing, it actually generated. I just wanted to show you that in fact the compiler, when you define a delegate on your own, the compiler will generate for you a class, okay, that has this delegate name, and it will contain 4 methods. The first one is going to be, I think 4 methods. The first one is going to be the method, actually it will contain 4 things. One is the constructor, and the constructor takes 2 parameters, or several ones. The first list of parameters is the stuff which you're going to pass in here. The second parameter is the integer pointer, so let's say int ptr, pointer to the function. And you're going to have 3 more methods: invoke, begin invoke, and end invoke. And this used to instantiate, or actually invoke, or like run the function which you are pointing at. Now, invoke is the one which you are using. Begin and end invoke are used for parallel programming or asynchronous programming. If you are programming, let's say, for Windows Phone, everything is asynchronous, I think. So if you would like to write to a on a text box, let's say, in a Windows Phone application, you have to say dispatcher, and then you say begin invoke, and then you write on the actually in the text box. So these are the 3 ones which you're gonna see. And if you would like to see here, if I hit the dot, you have begin invoke, you have end invoke, actually dynamic invoke as well as there, and this is it, an invoke method. You have those 3. I mean, when I've seen the compiler generated one, honestly I cannot get it here, unfortunately, but it's actually actual type. Also, I think it relates something to asynchronous stuff. Dynamically invocates late bound method represented by current delegate. I have actually searched for it. As far as I remember, I really cannot remember exactly, but I think this one is something regarding the asynchronous programming. Something regarding it. I can't really remember which one. Okay, this one returns an iasync and end invoke as well as iasync. No, it's bool. Okay, but again, it takes async results. All right, just I don't want to deviate away from the topic, but this is what the compiler will generate for you. It will generate for you, in fact, a class with the stuff. Okay, now Microsoft saw that this is gonna be growingly ridiculous. You're gonna have to type. Imagine that you have your application many delegates and you are utilizing many variations of them. And it's actually a repetitive code. So Microsoft said, okay, it's kind of stupid to write this. Let me give you 2 built-in types. Actually, 2 built-in delegates. The first one is action. The second one is func. Now, if you think about it, you have 2 types of functions in programming in general. A void function and a function that returns something, whatever that something is. All right. Now, if you would like to make your function return something, you're gonna have to use func. So if I say, let me undo this for a second. So if you would like to see the equivalent of this guy, the equivalent of this guy is func, actually t bool, close, predicate. This have the same effect as this. Okay, so this one is a built-in Microsoft stuff. It's a built-in .NET Framework stuff. It gives you two types of delegates that you can start modifying, you can start playing with. And right now, I could in fact replace this with func. Sorry about that. With again. Okay, insert. This is really weird now. Okay, I think I mistaken the insert key for the home key. Sorry about that. Okay, func. Yeah, I know that the insert was on, but apparently I was pressing the home key all the time instead of insert. Func t bool and then checker. Okay, exactly the same thing. If I hit Control F5, it will give me the same exact result from the last time. Now, how this actually works? What's happening here is you get a the format of writing a func is put in at the beginning all the parameters which you need that your function accepts. So let's say if I have something like this, delegate bool predicate 2, and I have here integer number, string name, and double celery, for example. All right, and you have a delegate like this. I could go ahead and make a func equivalent of it. So I could say, all right, the first parameter is int, the second parameter is a string, the third parameter is double. However, the last parameter always is going to be your result, your return type. That's what I meant by result. And then you name it. So predicate 2. Okay. And if we go over MSDN, let me see here. So func MSDN. And you can see here we have a bunch of them. This is actually for action. But anyway, right now this func, which you see right now in front of you, is a representation of a method that doesn't take anything and it returns a result, and it returns something. Where can I find you? Where can I find you? I would like to get the one with many guys of them. I don't know why I cannot get them. Anyway, I think you have up to 16. If you would like to see this, there you go. So t, comma, and you have up to a method. You can use the func to point to a method that takes up to 16 parameters. Okay, so you have a method that points to 16 parameters. Now you have a method that takes 16 parameters. Now it's up to you what you would like to have. And if you look carefully, the result is the end, like the return type. What you're gonna return. This is very important. So here I put bool. Now I put t here because I'm having a generic method. Otherwise I would put my actual type. Okay, so right now this is completely repetitive. I don't need this anymore. Now I just simply yanked out this part of the code. Now my code is getting slimmer and slimmer and shorter and much more efficient. Now what about methods that doesn't return anything? Void methods. Void methods, we have actions for them. So this is an action. An action could take one parameter, could take none, even this, and it could execute a certain operation. Okay? And you have up to 16 as well, I think. There you go, up to 16 parameters. So this is the equivalent of this. So if you have a delegate void something and semicolon, equivalent of it is action, and I think action something, I think. Let me see here on MSDN. Yeah, actually, let's see here. Where is action? So some value. Okay, show some value. Display window, display name. He actually took out the. Well, I cannot see the action used. Oh, there you go. There you go. Action. Yeah, so this one without actually parameters. Without any parameters. Okay, so let me go back here again. And if you would like to have a parameter, delegate void something to, the equivalent of it, the equivalent would be action of int and something to. So this is the replacement, the replacement of action and func for our delegates, that return something, and delegates that they don't return anything, which are void delegates. Okay. Now we made a shorter version of our code. Right now I don't even need these pieces of code, so just simply like take it out, and here I could just simply say I goes to I is less than 5. And as you can see here, my code is much slimmer. Right now I have only one method, and utilizing lambdas I can resolve the same problems which I had before. And lambdas and delegates of these types. Okay. I think this is what I wanted to talk about, to complete the idea of delegates, actions, funcs, lambdas. So right now we finished those 3 or 4 points. Actually, delegates we already finished them last time, but we were like reiterating over it. Actions and funcs and lambdas we were just completing or appending it on the last lesson. So are there any questions, guys, regarding this part, the actions and funcs and lambdas, of course? All right, we can continue. Okay. Now let's talk about and actually generic methods as well. We covered it. You see, we have already resolved it. And by the way, using the implicit typing again, which I mentioned the last time, we can actually get rid of this piece. So generic methods, we are actually done with it. But before I go ahead and hammer down a new detail, let me show you how to make an extension method. Okay, before I go ahead on yield. Now an extension method, imagine you have something for our employee, public void walk. Now our employee can walk in the corridors, right? Or, you know what? Get salary. So he can get a salary, so he can accept a salary. You know, like you give him his salary, he takes it and he's happy, and by the end of the month, as all we are, of course. This is the moment where everybody is waiting for the end of the month, right? Or the beginning of the month, if you will. Depends. Actually, beginning of the month. So Actually, the worst part is the end of the month. All right, so we have a get salary, and let's say you would like to spend it. Yeah, right, Imad, of course, end of the month, yeah. And the employee can be getting rich and rich and rich, but he cannot spend it. Now, how can he spend it? Now, imagine the following. You get a DLL, and all of a sudden your boss comes at you and tells you, okay, we would like to give the employee the functionality to spend his salary. How can we do that? What we can do if you don't have an access to this piece of code, you go ahead and you create an extension method which will extend the functionality of a certain class. In order to do that, you have several rules to obey. First of all, create another class. I'm separating here into a separate file just for convenience. I could put it here all into one place and it would be fine. And here I'm going to call this employee extensions. I named it that way. You could name it bleh if you want to. It's up to you. But here I'm going to call it employee extensions. Anyway, you will not need that name. That name would be irrelevant for you. The second thing, it has to be a public static class. Now, what is a static class? A class, as far as I read somewhere in MSDN, it says that this class is actually firstly loaded at the beginning of the project, when the project gets compiled. And it is sealed, and you cannot instantiate a new object out of it. So it is sealed means that you cannot inherit from it, and you cannot instantiate a new object out of this class. So you don't have a constructor for it. Now, how to write a static method, an extension method? So it has to be a static one. So public static. Now for me, I don't care about the return type for now because we're gonna spend the salary. So I'm gonna have it void for now. I'm gonna call this spend salary. Now the parameters is the most interesting part. You have to write it this employee and then the name of the object. You will not say that, but the employee object we are working with. I just written it that way so you can understand. I mean, you can have it like this employee imp, and we are good to go. It doesn't matter. Now, since this method is there, I can go ahead in my program. Let me first comment this. Control K C. If you look carefully at my employee here, if I create a new one, let me go over here and say just var emp equals to new, forgot about that, employee, and I say emp dot, you're gonna have the salary, you're gonna have this one, and you have get salary, right? You have this method. So I'm just gonna put here for convenience console.writeLine and getting yay I got my salary. How would you put this in a very cheerful way like this? Okay, semicolon. So right now you are happy you got your salary, and this is what you do. So if I hit Control 5, yay, I got my salary. And in fact, I'll just add this huge line and add one more. So yay, I got my salary. Now I would like to spend it. If I uncomment this code and I say here console.writeLine, yay, I'm buying PS4. I want to buy one actually. But anyway. Oopsie. So, I hope that imagine this, like a couple years later when you see PlayStation 5 coming out, and I'm recording this when PlayStation 4 just came out. Of course not. Xbox One, no, man. I would go get myself a PlayStation. I'm waiting for because PlayStation I think has a better thing for the indie guys. And PlayStation 4 plus 100 inches TV, come on man, you have a projector for that. Okay, let me just PS4 network, and PS4 network, of course. And if I go ahead here and I say imp dot, you see I got another method just appearing right there, and it says spend salary. You see how beautiful is this? And you see the small arrow pointing down, which says an extension. So this is an extension method, you see? So I'm extending the functionality of a class. And I even haven't touched this class at all, right? I kept it as it is. And right now I could get spend salary. And if I hit Control F5, so as you can see here, yay, I'm buying PS4. So you get those two. And as you can see here, I'm really happy because I got the additional A right there. So so it actually works, and it's really beautiful. You know what else you could do? You can not only extend the functionalities of a class that you have written, you can extend the functionalities of .NET Framework itself. I could say static void append crazy to string, this string str, and I'll say str plus equals crazy. Now watch this. I can go ahead in my program, have my string var str equals to hello world, comma, I'll let it be like this. I will say console.writeLine str dot append crazy to string. You see? And now I can just simply call that method, and we are good to go. Oh, sorry. Haha. I have to return it first, because you are returning that string, right? Because you take the string, append with the thing, and get it back again. Sorry about that, I forgot. And if I hit Control F5, hello world, you know, and crazy. And it will be happening for every string. Now, you could have really an extensive library to extend over the functionalities of string the things which you don't have, in which .NET Framework didn't give it to you. So, for example, right now you don't really need to tap into .NET Framework and into its source code in order for you to add certain functionalities. You have the extension method. You just simply grab a class which you'd like to extend over, and you just say, okay, this string class, I would like, for example, to add spaces every, I don't know, for every character, just add a space. So you will get a character space, character space, character space. So add spaces. Now you create such a method that just does that to string. You know, so you get all these extensible functionalities that you couldn't get actually before without extension methods. Now, this is the power which you have in your hand. Now, how far you can go with this? Well, you can go ahead and write even your own generic one. So public static, and let's say I enumerable of t, and let's say I don't know, crazy thought, and it takes this, and in fact it's a t as well, this I enumerable of t, that, you know, and right now here you return new return new list for now of t. Okay, just for now. Okay, because I don't know what I'm gonna do here, honestly. I just made this thing up. Now, if you look at this thing, right now I'm writing an extension method for every class that implements the I enumerable of t, the generic I enumerable. So if you look here, I could have str dot crazy thoughts or crazy thought. I could have lst or input. I think I have input dot crazy thought. I could have output dot output 3 dot crazy thought. You see, anything which implements the I enumerable interface will have this extension function, and it is really great because you could, let's say you have a specific type of a search or a specific type of insertion. So you would like, for example, to do an insert sort, or you would like to do a quick sort, your own implementation of fast quick sort, let's say quick sort 2, for example, which .NET Framework doesn't have it. You could have quick sort 2 or fast, and here you write the implementation of your quick sort. Right now I could have str.quicksort fast, and right there you can sort out anything. And this is the power of extension methods. This is the power which you can get. And if once you write them as generic ones, right now you even harness the power of being generic, that you can apply to any kind of class. Now, of course, if you'd like to do this sorting, you have to specify other parameters. Let's say this method, as you can see, this method doesn't take anything. I mean, if you look at this, at least, this method doesn't take anything. So if I give it something, and I do whatever I want here, so do whatever you want to do with something, right? And right here I can say quick sort fast, and you see it takes a parameter something. So right here I can type in something, right? Oh, sorry. Okay, so this is how to write an extension method that takes a parameter. The first parameter is always pointing at what you are extending. The next parameter is going to be the first parameter of the method once the user is going to use it. As you can see here, you don't see that piece. You see it only here, but you don't see it here. You see, it just takes this one right away. All right. Now here's the interesting part, which I wanted to show you, why I'm showing you extension methods. If I comment link, if I look here at str dot, you see how many methods in there? So again, other than append crazy to string, clone compare to, ends with, get hash code, index of, and so on and so forth, and you get all these interesting things, right? You get all the methods which belongs to it. If I uncomment link, right now you get even more, and you can see here even the bar is getting shorter because you got a whole bunch of extension methods just for you. So link is just basically a bunch of extension methods over I enumerables. So any method, any class that implements I enumerable interface, it can have this extension method. It can have this list of stuff. You see? This is basically it. This is what extension methods are all about. And this is basically what link is all about. It's just a bunch of extension methods. Okay, so since I got extension methods out of the way, this is it actually. Are there any questions regarding this topic, guys? Whoever is still attached to his PC. Okay, everything is clear. Smiley here, all clear, sir. So good so far. So far, so good, actually. Still on PS4. Ah, great. Me too, man. Me too. All right. Okay, let's get further. Let's even move further. Let us talk about yield for a second here. Now, does anybody of you know what is IEnumerable is? What IEnumerable is? Anyone? Okay. A little bit. Grabbing the infamous paint. Infamous paint. Let's get this on. Didn't. Now I'm gonna, for pedagogical reasons, I'm gonna just keep it simple and show it over a collection, okay? Because your class could implement IEnumerable interface without even having it, without even having a collection in there, which could be a little bit weird. But you know what? I could even show you its implementation in MSDN as well. So IEnumerable C#. I think I talked about it last time. One of the online classes. Maybe it's not recorded, but let's see here. Well, okay, okay, this is gonna be a little bit extensible. It's gonna be a little bit kind of big. Let me make it shorter. Now IEnumerable is okay, let me do it like this. So, you know, if you are trying, I was explaining this way on the classes. You know, there is a guy who hits. You know, if you are in a fight, if you are in a boxing fight or whatever, you know, if you are just in a fight and somebody has hit you and you being hit, like somebody just punched you and you're just being punched. Now, the question is, what is the name of you guys? So there is the hitting guy, so the hitter, I don't know. And there is, and you are becoming a hittable guy. So you can be hit. So hittable, capable of being hit. And this is in fact what the IEnumerable and IEnumerator is about. If I'm saying that this list is enumerable, it means that I can enumerate over it. And if you think about enumeration is just something like you go over every piece. You can think of it that way. Actually, enumeration here, you can use IEnumerable and IEnumerator to generate a bunch of sequence, because IEnumerable describes a sequence of something. Okay, this is what it actually tries to describe. And you can enumerate over the sequence. You can go over each part of the sequence using an enumerator. Now, what happens here is, for the first, let's say, and by the way, for each loop works only on classes that implement the IEnumerable interface. Okay? If your class doesn't implement the IEnumerable interface, it's impossible to for each over it. Now if you look here, at the first loop, in your for each loop, you are standing right here, let's say, and then the first loop, you enumerate, your enumerator says move next, and you have in fact a method called move next, which is a boolean. Okay, it says could I move next or not, or I mean if it doesn't, if the move next fails, if you fall out of here, it will return false, and it will say right now you came to the end of the array. Okay, and it says, and here you can get the current item, and it's only a getter, so you get only the item. Okay, now if you look here carefully, getting the current item, it returns you an object. Okay, but as you can see here, it is only a getter. So that's why, if you remember at the first time when I was teaching about the for each loop with the tree and the apples and all these stuff, if you remember, I told you it's a read-only loop, and it is because of this. Whatever object is returned to you, if you have got an apple, you cannot change it to an orange. You can change the properties of the apple. You can say the current object which I'm pointing at dot name, change it, but you cannot change the current object which you are having it to something else. Exactly, Almir, Colin the monkey, right? You remember it. So yeah, so basically your enumerator just simply are pushing, moving forward, so you move next, move next, move next, and every time you move next, you get the current item, which you are actually at, until it just the move next returns false, and this is it. Basically, let me see here if actually the compiler expands the for each loop here. I would like to see this. So this as well, the extension methods. Let me see. Let's hope. Does it say anything? No, it doesn't say. It didn't really expand it here. Let me try to replicate what the compiler will expand this for loop into. It's gonna be something like this, as far as I remember. Var enumerator equals to output for, I think, dot get enumerator, and right here say while enumerator dot move next var item equals to enumerator dot current. Right now, this starting from here is the body of the for each loop. Okay, so right here you start the body of the for each loop. Right here you say console.writeLine item. You see, and your item, by the way, is going to be with the type of you had. So the current is the employee. You see, because because we are using enumerable of t, so that's why it's generic. All right. Do you get the idea, guys? I didn't want to implement it. I didn't want to implement the enumerable interface. It's already in MSDN. You can feel free to read it, but it's very, very important that you understand that this is the part where move next comes in, and you start, you know, like going over every item and so on and so forth. This is very, very important. Do you guys get this point? How your for each loop expands to this? Okay. Okay, so this was a yes from one. Alright. Alrighty. Now, why I was bothering you with this detail is it? This is the most important point about yield. This is where actually yield plays its magic. If we look carefully here, a yield would look like this. In order for you to understand it, I will just return an enumerable of int, and return bunch of numbers. And right here I will give it my input, list of int input. Or you know what, I will not even add anything. I will just show you this one. Yield return 0. Yield return 1, yield return 2, yield return 3, yield return 4. Okay. Now, I am really sorry, but I'm gonna surround this. I think there was a feature in Visual Studio where you can in fact surround this with okay, it doesn't matter, because I don't want to erase this code because I don't know when I'm gonna use it again or when I'm gonna refer to it again. So I just move it inside this region. Unused code for now. Just collapse it. So we have a clean code here. And if I say var something equals to return bunch of numbers. Okay, so whatever I'm gonna get out of this thing, I'm gonna get, you know, that something. And this is very, very interesting part. If I say for each var item in something, console.writeLine item. And in fact, in order to make this output clean, I'm gonna comment this code like this. Okay. Now I'm going to hit Control F5 so you can see the result. 0, 1, 2, 3, 4. Interesting, right? Now let's even see a mind-blowing thing. Since F9 is not working, I'm gonna put here a breakpoint by hand. Okay, and let us start our application. Now, since my recording program is still actually is following F10 as stop, so that's why I'm gonna use the mouse button here. Actually F11. I'm gonna step into using F11. Now, you see I stopped the breakpoint right here. Now watch this. If I say step into and move along, it just didn't do anything. You see, the method hasn't been called yet. Now, if I move in here for every item in that something, now it actually jumps into the method. You see, and then it calls it. So it returns 0, and you move on. It returns 1, you move on. Returns 2, returns 3, then returns 4. And you end up with the execution of the application, and then you get 0, 1, 2, 3, 4. Now why is this happening? As you can see here, any yield statement, it doesn't work unless you for each over it. Alright? And if you would like to for each over it, if you would like to see the compiler result of this, if you would like to see what the compiler generated for you, it's going to be something like, let me see here. Yes, it refreshed. Now you see, I have got a new sealed class, a method, the method has been converted into a class. And then my move next has been inserted with 0, 1, 2, 3, and 4. So what yield statement does, it injects code inside your move next statement, inside this IEnumerable move next. This is what yield does. It literally injects the code right in there. How good is this for me, right? You see this? I could even take this out. I mean, sorry, let me just, because I've done it a little bit faster. Let me even delete this. I don't need this anymore. And I will erase this piece. Now I could utilize yield for my benefit. Right now I could take out the result, this result thing, and I could item check yield right here. Yield return item. And if we don't return anything, we just simply return null. If we don't return anything, we just simply return null, I think. What did I do now? The body of cannot be blocked because the iterator is cannot iterator block. Oh, wait a second. I think I have to, let me see here. What am I having? Aha, okay. It's not an iterator type of an interface. So let me enumerable of t. And now maybe we'll get into a problem. Let me see, Control K, C, okay. Now we are good, okay. You have to always return an enumerator or enumerable. So this is the part where the compiler was complaining. Okay, so I don't even need these lines of code. You see, right now your code is even shorter. Let me even Control KU and Control KU, and right here I'm gonna make a for each loop for each item in my output 3 console.writeLine and item, and right there I could hit Control F5, and you see get 1 and 4 because they are the only ones which are less than 5. Now still, I mean, this is not only shortening it, it's not shortening only the code and make it more efficient. It's imagine this, you are trying to, let's say you have 10,000 employees and you would like to stream them over, you know, from one place to another, and you are in the meanwhile you are checking over each one. You are making a for each loop over each of those 10,000 employees. If you found what you need, you could just simply say yield break, and boom, you break the whole thing. Right now you will just, you know, if you found your employee, you'll just simply break your loop and you get out. And you don't have to wait, let's say, for another side of your application. Let's say you have a server side of the application and you are streaming 10,000 employees online, for example. You could, and while you are searching for one of them, you could, for example, reach that employee after 2,000. Now, after 2,000 you reach it, you will return it, and this is it, and you cut the connection, you cut everything. The old way of creating a list of the matching employees, for example, of a certain case, you will have to wait for the server side to compose for you a list. So it will have to loop over the whole thing, let's say 10,000 times. And then once it reaches to the first, you know, to the second or third occurrence, until it reaches to the point where you want to, you know, and then fill the list for you, will return to you the whole thing. Right here, you are actually streaming it, really live. Okay. Now this is maybe a little bit far remote example. There are many uses of yield as well, other than maybe streaming, but this is basically what it's all about, you know. Much more efficient code, basically. You will see it in Unity 3D with coroutines, and it has a different story why people are using it. We're gonna probably, hopefully in computer graphics, once we meet there, we're gonna see what are coroutines and how they work and so on. But this is what yield is in fact all about. For now, this is for the C# feature. All right, any questions regarding yield? It's a little bit awkward piece of code, but it's really looking nice. If you would like to see what the compiler has generated for you, it's kind of interesting, honestly. You'll see weird stuff. There you go. So a public sealed class as well, which is right now your method converted. You know, they made it generated a class for you. And right now it's not a state machine anymore. It is something a little bit more complicated. So if I go to move next, you get a specific while loop inside it. You have a goto statement. You have a weird thing is going on in here. So it's something that I think you cannot generate by your hand because the compiler doesn't support this. This is like I mean the syntax. I mean if you cannot write a syntax like this in C#. I think, for example, this fold thing, it doesn't exist as a syntax in C#. The compiler has it, understands it, but it will not compile it from your text. So it's kind of difficult that you're gonna write your own generic code for move next and inject everything here. Now, of course, this was a replacement because a lot of people were sometimes injecting their code inside the move next. So every class they have to implement IEnumerable and IEnumerator, and then they push the move next code inside here. Right now, yield resolved that problem and generates the stuff for you. So yeah, this is it. Now, sorry again. Any more questions regarding this topic? All right. We use yield when we want to return an IEnumerable thingy. No, yield when you try to return yield return works only when your method returns an IEnumerable. This item, I mean the item is an integer, right? And if you define an I think integer int I equals to 0 and I dot, you see, I doesn't implement the IEnumerable interface, but your method has to return either IEnumerator or IEnumerable. I think it will work fine as well. Okay, so IEnumerable. IEnumerable. Okay. All right. I think this is it. If there are no further questions, I will conclude this lesson. And by the way, this is right now I hammered down all the features which we need for our class. Yield, maybe I went a little bit ahead, and yield will not be seen in your practical tests or something like that, but it's good for you to know, and I mean good for you to know about them. I think if you go to okay, yield, if you look here at the reference, you have yield return and yield break. I guess, can we get fantastic code? Oh well. Okay, which piece of it? I can send you the code. Okay, I will send it to you. How about this? Okay, let's do this after we finish recording, shall we? So we're gonna figure out how can we send this code. Now, this yield, there you go. This is the reference, the MSDN reference about yield and how it works and why could you work with it, why it could be cool. So this is one thing. Second thing, if you would like to dive into more in C#, because from now on I'm going to move on to another topic, communicating with database, getting stuff from database, and so on and so forth, is CLR via C#, 4th edition. Very, very good book. Really awesome book. I advise you to have a look at it if you would like to gain an in-depth understanding of how C# works from the inside. It covers really a lot of interesting topics: how the compiler generates the code for you, why things working as they are in C# and so forth. It's very very good book, and as you can see here, 26 customers give it like 4.9 out of 5 stars. And I honestly, it's quite rare that I buy, let's say, a book on a specific programming language, because usually they tend to get outdated really quickly. But I think this is a very good reference for you to understand how a language works from the inside, that even in the future, let's say if you would like to create your own, let's say you would like to get your own, how can I put this, let's say your own feature in a programming language that doesn't, let's say, support a certain thing, and you would like to improvise, and if you know the inner working of, let's say, C# and you would like to implement some sort of a feature that doesn't exist in another programming language which you are working with, by your understanding of the inner working of C#, that feature which you are seeking for, you can implement it on your own. So it's kind of good thing to read such a book. And it's a reference book, so it could be very interesting. All right, now actually my eyes just fell on this one, which is great, which I'm gonna be looking at this here. So thank you very much for your attention, and since there are no further questions, I will stop recording right here, and we'll see about sharing the code after the recording. Okay, so see you next time.